Okay, let's look at another optimization problem, this time maybe like one with a function or on a graph. It says the maximum possible area of or find the maximum possible area of a rectangle with a base on the x-axis with two upper vertices that lie in the graph of the equation 12 minus x squared. So on this one, for what we know here, let's see if we can get that graph. Let's graph it out. This is going to be a parabola because it's squared here. This would be the y-intercept because if x is 0, we're going to get 12. So 3, 4, 5, 6, 7, 8, something like this is going to be the a point on there. And then because the x is negative, we know it's going to be opening downwards, or the x squared, I mean, so it's going to be opening downwards, something like that. You could graph it on your calculator too to kind of check that that's what it looks like. So that's the graph. They say there is a rectangle within this with the base on the x-axis, so the bottom's on the x-axis. What's the biggest rectangle that we can fit in that parabola that looks like that? So that's what we know. What we have to show, or what they're asking us to find, is what is the maximum possible area. And so we want area of this. Area of a rectangle, you know, is length times width. But how do we kind of connect that to our problem here? Well, we also know from over here that these corners are intersecting that. That's our connection. The rectangle is connected to that parabola through that. Well, any point on there we could call x, y. And so if that point right there is xy, that means the distance here is x, the distance here is y. And so we can relabel this area equation in terms of x and y then. The length up across here would be, well, if that's x, that's also going to be x. So the total length across this would be 2x. So we'd have 2x times, and then our length or our width or height here would be y. So our area equation in terms of x and y would be 2x times y. All right, so now in these optimization ones, our goal is to find the maximum by finding derivative, but we don't want two variables there. We'd rather get it down to one. So how do we get it down to one? Let's use what we know here and do that. We know y squared is equal to this. If we plug that in for y here, now we're down to one variable. So now our area equation becomes 2x 12 minus x squared. Let's simplify that before finding our derivative. So 24x minus 2x cubed. Now let's do our derivative. So we got 24 minus 6x squared. We know maximums, minimums happen where derivative is equal to 0. Continue solving this. Got that x squared equals 4. And so we're going to get that x is equal to either plus or minus 2 there if we take the square root. Which one is the one we want to go with? Probably the positive one here, since we know it's going to have to be, well, actually it ends up being both, that x could be either positive 2 here, negative 2 it looks like. But if you want to find the maximum one, I think we're going with positive so we could find the positive area here. But again, to show that the positive one is the maximum, we could go ahead and use that second derivative test. So second derivative here would be derivative 24 is 0. Derivative of that other part is negative 12x. So if we plug, what's our second derivative here at positive 2? It would end up being negative 24, which is less than 0. And we know if the concavity is negative, we have a maximum here. So this would lead us to a maximum at 2. If we did it at -2, we get positive 24. That's bigger than 0. So that concavity is concave down. That means this is at -2, that's a minimum. So our maximum is going to be +2 here. So we know when x is +2, that's what we're looking for. So here we know x equals 2 is part of our answer. Let's find the y like we've done in the previous problems here. Best place would be right here. So y equals 12 minus 2 squared, plugging in the 2 we got before. That's going to give us a y of 8. So y is 8. Now you got to be careful here. The couple problems we've done before this, that was it. But they did say find the maximum possible area. So we're not done yet. We need to find the area. Now let's use our area equation that we came up with in terms of x and y. Plug those in and get the area. So the maximum possible area would be 2 times our x value times our y value. And so it looks like maximum possible area would be 32, whatever these units are. So make sure you answer the question. If they ask to find the max area, then find that.